Hey everybody, welcome to another Con support video. This one is on rates with fractions. Alright, so let's go over the skill and see if I can help you figure out how to do this stuff. Alright, so let's go. So it says here, let me zoom in a little bit for you. It says here, let me move this up, let's say to there. Okay, perfect. Robert climbed 775 steps in 12 and a half minutes. How many steps did he average per minute? So these problems are pretty straightforward. You just need to think about what the rate would be. And the rate is just going to be, in this case, it says steps to the average per minute. So we're looking at steps per minute. So we want to have the steps on top and want to have the minutes on bottom. Okay, so it's steps per minute, right? Steps per minute. And so in this case, it says there's 775 steps, and he does that in 12 and a half minutes. Okay, so 12.5 minutes. So now you've got your ratio set up. If you want to figure out the steps per minute, all you have to do is divide top and bottom by 12.5, or by the denominator in this case, right? The number of minutes. So if you do that, what you're going to get is an equivalent ratio where the denominator, the minutes, is 1, like you want, and the top is however many steps this person can complete per minute. So let's just do this quickly on a calculator. I don't feel like I want to make the time about this about dividing. I think you guys get how to divide, I hope. If you want to, I guess you can just do this one pretty quickly. How many 12 and a halves go into 25? That's 2, right? So dividing by 25 and then just double it, basically. So if you divide by 25, you're thinking about 7 times 4 to get 700. So that'll be, what? 7 times 4 is 28. 28 groups of 25 are going to make 700. And then you got 3 more, so it's going to be 28 plus 3, so it's going to be 31. 31 25s go into 775. So that means that 62 would go into 62 12.5s would go into 775. So you can do it mentally like that, but let's just double check. And so that would be 775 divided by 12.5, and that would be 62. Okay, so the answer would be 62 steps per minute. So that's 62 steps per minute. Steps are on top, minutes are on bottom. This is your rate, it's your unit rate. If you write the equation for this, it would be y equals 62x, where x is your, this is the ratio of y over x. So x is your number of minutes, that's your input, and the output y would be the number of steps, right? So you guys can see the relationship between the unit rate and the equation, right? Unit rate is the multiplier of the equation. That's kind of how it would work. So it says how many steps did he average per minute? That would be 62 steps per minute. All right, let's do the next one. So it says Ben drinks tea at an incredible rate. He drinks 3.5 liters of tea every 2/3 of an hour. Ben drinks tea at a constant rate. In other words, they want to know if this ratio stays the same throughout the drinking process. How many liters of tea does he drink in 1 hour? So if that rate stayed the same, how many would he drink in 1 hour? So once again, the main goal here is to understand the ratio. So in this case, it is how many liters of tea does he drink in 1 hour? So the top value is going to be the liters of tea, and the bottom value is going to be the number of hours. Okay, so it's basically liters of tea per hour. Liters of tea goes on top, hours go on bottom. You want to put the information into the ratio and then use that to help figure out what that would be as a unit rate. So we know that it's 3.5 liters of tea every 2/3 of an hour. Or if you want 3.5 for every 2/3, if you like it better as a fraction, it doesn't really matter. It's the same value. And so if you know that it's going to be 3.5 every 2/3, then what would it be for every 1? So all you have to do to get that value is just divide top and bottom by 2/3, right? So if you were to divide the top and the bottom by 2/3, you're creating an equivalent ratio, but now it's out of 1, which is our unit rate. So in this case, you're going to have 3.5 divided by 2/3. That's going to be 6 plus 1, which is 7. 7 halves, that's your top of your fraction, divided by 2/3, which is the same as 7 halves times the reciprocal, 3 halves. And then you're going to multiply across the top, across the bottom, and you're going to see that that's 21/4. How many times does 4 go into 21? 5 times with 1 left over, so it's 5.25. Okay, so if you're doing 3.5 every 2/3 of an hour, then you're going to do 5.25 in every hour. So it says here how many liters of tea does he drink in 1 hour? You'd write 5.25 or 5 1/4. And that would be the answer. You could put 5 1/4, you could put 5 1/4. You could write it like that, 5.25, or you could write it with space and then 1/4, 1/4. If you're going to do it as a mixed number, it's always one space between the whole number and the fractional part. And that's the answer, okay? So that's how you do it. By the way, on this last equation, right, if I asked you what the equation for this would be, it's just the unit rate, which is 5 1/4 over 1, right? If this is your y and this is your x, right, always the ratio of y over x, then you would just say that the y is always going to be equal to 5 1/4 times the x, right? So when x is 1, y is 5 1/4. So when x is 2, you double the top and bottom, right? So when you input a 2, you just times 5 1/4 by 2, and you get the y, right? The output. So this is the equation that models this proportional relationship. So if you had to write the equation, that's how you do it. Let's go to the next one. The next one is Jessica's a custodian at Oracle Arena. She waxes 20 square meters of floor in 3/5 of an hour. Jessica waxes floor at a constant rate, so it's proportional. At this rate, how many square meters can she wax per hour? So once again, we're doing square meters per hour in terms of the rate at which she cleans the floors. So you're looking at square meters per hour as your units. Square meters on top, hours on bottom. If you want to set that up, that's a ratio of y over x. If you were to make a table or graph it, right? So y would be the square meters that she's cleaning, and the x would be the hours. In other words, input hours, times it by the rate she's cleaning at, and you're going to get the output, which is the amount of space she can clean. In this case, we're given some facts. The facts that we're given is that 20 square meters are getting cleaned every 3/5 of an hour. So you don't want to know how long it's taking, how much she cleans in 3/5 of an hour. You want the unit rate, which is how much she cleans in 1 hour. So because you want the ratio of how much she cleans for every 1 hour, you're going to divide top and bottom by that 3/5 to create your equivalent rate. That's a unit rate. So all you have to do there to solve it is just going to be 20 divided by 3/5. And as you know, that's the same as 20 over 1 times the reciprocal of 3/5, which is 5/3. So that's going to be 100 over 3, or 33 1/3. So this is going to be 33 1/3 for every 1 hour, 33 1/3 square meters per hour. And that will be your unit rate. So it says at this rate, how many square meters can she wax per hour? So you can do 33 1/3. So just 33 space 1/3. Okay. The last one here says Uncle Drew scored 28 points in 5 5/6 minutes during a basketball game. How many points did he average per minute during that 5 5/6 minutes? So basically saying over that period of time, what was his average speed of scoring baskets? What was his points per minute, basically, over that time? Which means points is going to go on top and minutes is going to go on bottom. So your top category is the number of points you scored, and the bottom category is the number of minutes, right? And so the ratio of y over x is going to be the points per minute. And so all you got to do is put it in. I got 28 over 5 5/6. We know we don't want the ratio of how many points he scores in 5 5/6 minutes. We want to know the ratio of how many points he scores every single minute on average, right? So all you got to do is change this to an equivalent ratio where the denominator is 1, right, where the minutes is 1, which means you're going to have to divide top and bottom by 5 5/6. So if you divide top and bottom by 5 5/6, you're dividing by a giant version of 1. It's not going to change the value of the ratio. And you're going to get the correct answer. So all we have to do mathematically is 28 divided by 5 5/6. So over here we go, and we figure that out. So 28 over 1 divided by 5 5/6. 5 times 6 is 30, plus 5 is 35, so that's 35/6. That's the same as 28 over 1 times the reciprocal of 35/6, which is 6 over 35. You then look to see if there's anything to cancel, top and bottom. So is there any common factors that you see? I see that you can divide both 28 and 35 by 7. 28 divided by 7 is going to be 4, and 35 divided by 7 is going to be 5. And then you're just going to multiply across the top and bottom and finish strong. So you get 4 times 6 is 24, and 1 times 5 is 5. How many times does 5 go into 24? That's 4 times with 4 left over. So you're going to get 4 4/5. So basically at this current rate, right, if he maintains his rate as an average rate over that period of time, over the 5 and 5-6 minutes. Every single minute he was achieving 4 4/5 points, or 4.8 points. So he was getting 4.8 points per minute. And that would be your rate. If you want to do an equation for this one, guys, it would be real easy. That unit rate is your multiplier. Okay, so if x is minutes and y is points, then the equation would be y equals 4 4/5 times x. And that would be the equation that models this relationship, because your unit rate is what? 4 4/5 points per minute. So here's your answer, 4.8, which is the same as 4 4/5. And we're done. And that's how you do rates, right? It's just the top divided by the bottom, basically, because you're creating an equivalent ratio out of 1. Let me stop this, and we'll go to the next one.